Hi guys, so this is the I'm Anthony in charge of putting you guys through IEEE stream and prep. So you guys are most likely on this group because you already know trying to prepare you guys for the IEEE stream competition. 24 hours of competitive programming is waiting for you. And discovered that most of you have close to, if not none, programming knowledge, which was okay. We said, all right, we're going to train you guys, not really train, but give you resources in order to be able to understand the basics, that you'll be able to compete in this competition. This is the webpage, ieextreme.org. What is IEEE Extreme? IEEE Extreme is a global competition in which teams of IEEE student members, advised and proctored by IEEE members, and often supported by an IEEE student branch, compete in a 24 hours time span against each other to solve a set of problems, right? So basically, members of IEEE student branch compete against themselves for a whole day to solve sets of problem. It's basically competitive programming. And then they put the prizes. Yeah, the prize is actually nice. And the goal for IEEE Unilag student branch is actually to be top 100. Yeah, or even first or second. There's nothing really stopping us from getting first or second. But in order to do that, you guys need to be well prepped in your algorithms and data structure. So I will just go brief intro what algorithms, what are data structure, what you need to know, and how to use lead code to get better at solving algorithms and data structure. Right. So a simple Google search will show you algorithms, a process or a set of rules to be followed in calculation or other problem solving operation, especially by a computer. If during your secondary school days, yeah, if you did computer science, you could have learned what algorithms are. They are actually like I remembered in school where our teacher was like draw a square. I think as I saw so with write an algorithm to draw a square. Let me show you some images. So you have an input, right? Then you write the instruction. Then you print out your results or gives out your results. The algorithm is the instruction. The input's taken, like that is done on the inputs basically. Yeah. So imagine we had to draw a square. The algorithm for that would look something like draw a straight line. Then at angle 180 or angle 19 of that straight line, draw another straight line with the same length. Then at angle 90 again, draw another straight line. Then at angle 90 to the axis must be specified. Y-axis, upper y-axis, positive y-axis, draw another straight line, then negative x-axis, draw another straight line, same length. That would be the algorithm to draw a that would be the algorithm to draw a square. So basically, just think of algorithms as step. You are given a problem. The first thing you should do is to write pseudocodes. Pseudocodes and algorithms are a little bit different. So pseudocodes are basically algorithms without any languages, like pseudocodes. Let me just before I can say rubbish. Pseudocode. Yeah. The main difference between algorithms and pseudocode is that an algorithm is a step-by-step process to solve a given problem. Okay. So algorithm is a step-by-step process. So algorithm shows you every step. Why pseudocode doesn't generally show you all the step, but it just writes it in plain terms that anybody should be able to understand. So I'm not writing all the step. Like now, when I was explaining how to draw a square, draw a line on the axis, draw another line with the same length, 90 degrees, draw another line. That is a pseudocode. Yeah. An algorithm would be the exact step. So use create an element, initialize it, depending on the tool you are using. Probably you are using JavaScript and you're using something like Tinker in Python. You would have to initialize Tinker. You'd have to get a node. You have to draw a line, stuff like that. Each and every one of those steps. Compared to pseudocode where it's just plain English, they just draw a line 90 degrees perpendicular to each other. Yeah. So most of the time when I send problems to the group, I most likely am asking for um your pseudocode. Like what approach would you use to solve this problem? And that will take us to data structures because there are a lot of methods to solve any problem. Like there's no just one single method to solve any problem. And you see that when we go to LeetCode. When you check the LeetCode discussion section, you will discover that there are so many ways to solve a problem. Yeah. And you can think up of new ways that have not been written before or cannot even be found in discussion or those bots used to do it every time. So what are data structures? Basically, if algorithms are step-by-step process and pseudocodes are just layman understanding of algorithms, then let's see. Data types and data structures are ways of arranging data. Because most of the time data is given, you manipulate the data and you print out the results. The data that you are given and the manipulation that will be done on it, you would need to be able to store them, utilize them, read them, and do sorting, um, some sorting algorithms on them or search algorithms or something like that. In order to be able to write any algorithms on them, you need to be able to store them somewhere or structure the data. Probably you are given random data now, you have to sort them in order to proceed. Right. In order to do that, you would need a data structure. And these are where data structures come in basically. A data structure is a collection of data types, stored and organized in a particular way that allows it to be effectively accessed. I'm not reading directly from here, by the way, so effectively accessed and modified. So basically, there are ways for you to store data that allows you to be able to effectively access them and modify them and do a lot of other operations on them. We have various type of data types. We have the stack, we have the queue, we have the Paris queue, we have the trees, binary trees, heap trees, we have the graphs, we have maps, we have sets, we have a lot. Most of the time, you will not need to learn all of them. You just need to learn the essentials. Like now, I think everybody should know what maps are, and everybody should be able to create a map. Or you can use objects to create a map in JavaScript, and everybody should know what sets are. Sets are basically collection of data, but what's special about the sets is the way they store data. They literally can store anything, but they can store only one occurrence of that thing. So they are not duplicating a set, right? A map stores data, but in terms of key value pairs. So they are very good when you are looking for probably occurrence, how many times this occurs, because now you can put the value there and the key would be the item and the value would be the amount of time it occurs. Then you can compare. Probably want to check the highest occurrence in an array. Using a map would be good there. Using a set will not really do it because you don't need uniqueness here. Then another place where you could use a set is if you have to find if you are given a question that you should remove or duplicate and find the highest element and the element cannot exist twice, or a question that states that something cannot exist twice, you generally have to use a set because you can use a map. You just check the key each time you want to add to the map. If it already exists, remove it, something like that. That's why I said there are several ways to do it. You can use arrays for almost any question. Most of the time, they'll be the brute force approach, but it's going to work. Right. I'm checking the time here because I don't want these videos to be long. So I would be sending this link. I think they did a very good job on explaining various data structures and the basic data structures, and you could look into them. Then let's go to Lead Code. Lead Code is a platform that helps you prepare for most of the time FANG interviews, because these are what they're going to ask you. But you can also use it to prepare for IEEE Extreme. Although Top Coder and Art Coder are what was advised for competitive programming. But I think for beginners, like people on the group I'm sending this to, you start with Lead Code, and once you feel that you can solve most questions by yourself, even if it's brute force approach, you can go to Art Coder or something else. But Lead Code is not only the it's not the only platform we have there. We have CodeWars, codewars.com. Because I also like CodeWars. Yes. So this CodeWars, this is my profile. They have things like Q. They gamified it, so this was very, very lovely. Because they have things like ranks, honor, leaderboard, honor percentile, stuff like this, language, JavaScript, most recent JavaScript. I only use JavaScript, to be honest. And they give you very, very interesting questions. Like very, very interesting. But I use Lead Code now because this is the questions from me are mostly from if you're applying for all this FANG company, Facebook, Google, Amazon, Microsoft. Yeah, use them. But I loved this interface. I still love it. So you can come here, search for questions on array, strings, hash table, dynamic programming. All these are all the concepts. Like, you don't need to learn all of them. Backtracking. Yeah, you have both algorithms and we have data structure, algorithm, math, algorithm, sorting algorithm, greedy algorithm, database, breadth first, breadth first search algorithm, binary search algorithm. So let's solve one. Okay, or two. Let's just solve something and see. We'll click one, and next time, because I sent the problem to the group chat and um I asked for solutions. You guys did not really reply, which was like meh. But I want to show you next time I send like a question to the group chats what I expect from you guys. Someone replied, yeah, but it's also off that my brain could not process it. I was already tired and I did not just want to think about it. When the algorithm is given to you to solve, you're not to change the parameters or change the question. Solve it like that. Because most of the time, I give you the question, I'm expecting to see solutions pertaining to the question. And that's why I always drop the Lead Code link. I've solved this before. Yeah, I've solved it. So let's read the question. I think I sent this to the group. This was the question I sent to you guys. It was easy. So I was like, all right, it should be easy enough. Given an array of integer, basically an array is literally like a list. In JavaScript, the language I use, you define arrays by doing let r because so this now I've defined an array. So given an array of integers num. So we know the array will contain number like 1, 2, 5, 6, something like this. Array can contain different types, A, B, C, stuff like that. And the target, return the indices of the two numbers such that they add up to the target. So they want to find, you are going to return the indices of the two numbers such that they add up to the target. All right. You may assume that each input could have exactly one solution. So always read the entire question. You know what problem? I was trying to remember what problem in secondary school. I do give you and you'll be reading according to comma. Yeah, your word problem skills, logical skills, like they help you think logically. So given an array of numbers and an integer, comma. So you have been given this and that. That's one statement. Your return statement should indices of two numbers. so that they add up to the targets. Return indices, okay, return indices of two numbers so that they add up to the target. So we are not returning the two numbers, we are returning their index. You may assume that each input have exactly one solution. So you are never going to find a test case in which there will be no solution. So you don't need to check for that. And you may not use the same element twice. Okay. And you may not use the same element twice. Okay. So two numbers cannot add themselves. You cannot use 0 and 0. Probably your target is 8 and there are two fours here and there are 4. Wait, let's say they are unique. Probably they are, oh, you cannot use the same element twice. If you can, there's exactly one solution. You cannot use the same element twice. You can take this number and convert it to a set because they didn't say all elements will be unique here, but they said we cannot use it twice. With that, I can just convert it to a set and wipe out any recurrence of it. I'll use a brute force approach, then I'll use like an optimal solution. So you see the time difference. And by the way, the fact that I'm writing JavaScript, C++ is the advice language. Compared to when it comes to speed, this is competitive programming, they'll be checking for speed. C++ is freaking fast, like 2 times faster than JavaScript. That's the language I advise you to learn or use. And to do that, you just come here and select C++ and you can start. But that's not me, and that's not today. So the brute force approach would be to go through each and every one of this number and check if they write a for loop, right? There's for loop, that's nested for loop. I check this plus this, then this plus this, then this plus this if they added up to 9. I'll show you 3 solutions and their different efficiency. So the first one is to write a for loop. I'll first have to define let results res for results equal to this array. Then the brute force approach for let I equal to, yeah, if you guys took the courses I sent to the group and the links, you guys should be able to write basic for loop, understand what arrays are because they are basic data structures in whatever language you're using. I is less than nums.length I plus plus. I'll write another for loop. Let's, and also you have to be careful about complexity, and this is where let j equal to 1. This is why we have several solutions. You would see why j is less than nums.length. J plus plus. So this is a nested for loop. Time complexity is already O of n squared, which is bad, given that we can use, could have used things like maps to easily run this. So I would explain how you use maps to solve this. So I will not do nums. If write an if condition, if nums I plus nums j equal to targets, return an array that contains I, comma j. Let's see if this works. It's accepted. Will this pass all the test cases? Let's check. I'm doubting it would not. Yeah. Why didn't it pass all the test cases? Because we are not checking for uniqueness. Given that we cannot have 2 numbers at the same position. So like 1 and 2. Okay, so you could not have two indexes. This is 0, this is 1, this is 2, expected 1 and 2. I plus j. So this plus this plus this plus this. Okay. Then that's round finish. And 5. Oh. This would always be 1. Which it should not be. It should be incrementing. I plus 1. Let's see. I should have removed duplicates. Let's see if this will work. Yeah, it passed. So time complexity. This and this. It's worked. Probably test cases a little. Then another approach to this, to solving this, as I said, there are several approaches to solving this problem. Would be to use a map, right? So we'll just let my map is the data structure that holds key value pairs. Go to new. How many minutes is this video? 21. This should not pass 30 minutes. Sorry that it's getting this long. Maps. Map in JavaScript. Because there are two maps. There are array.map and then there's the map. Yes. So you can read up on all the properties of map here. Let me check map data structure. Map holds. Okay, they show you how to create a map. They hold key value pairs, which we would use in this problem. Another approach to solving the question. This was what I wanted to solve, but time is not really at our side. I wanted to solve the question this and this, but since time is not really on our side, we move. So come here, initialize new map. Let me move this to this. Then loop through the elements once for let I equals 0, I less than norms.length I plus plus. Okay, that's the first loop. Then what do we want to do in this loop? We want to check if the elements. So I want to check if we add elements to the map, right? So if we subtract the current elements from targets, right? So if you, let's say 7 minus 9, 2. We check if 2 is in the map already. If it is, then return the indices. So do temp also targets minus norms, we get the current in this. Okay. Now we check if the map has my map as temp. Because yes, map has a dot as property. And this is why you have to be conversant with your data structures. Okay. So dot as. If this is true, then we return an array of my map. Okay. Else we return the that is not on the map, like it doesn't have temp. We add temp to the map plus the index. My map dot set temp and height. I think this should work. I think. Let's see something if for log. I want to check debug your algorithms. Yeah, 27 minutes. Getting too long. 7 is got 0. So as the key. I've solved this. Let me check my submissions. I'm coming. Because time is not on our side. I think I'm checking wrongly. Map.get. But as temp. I was set. Or is it the other way around? I'm coming. Map.get comp. Yeah, we are using complementary complementary numbers basically. The get number I set I. Is that an else? Yeah, it is. So this is my solution, the one I wrote before. Yeah, they are basically the same thing, so should work. And you can see the time complexity, although this code does not always show like that, but you can see. Now the time complexity for this is O of n. Yeah, the previous one we showed was O of n square. So it's almost 30 minutes. So that's ways to solve an algorithm. Hope this was self-explanatory, hopefully. I wanted to post the code, but that would be problematic. But I'll be posting the links to this problem for you guys to attempt, try other solutions, and see what you guys come up with. I'm solving it. Right, guys. Bye. It's already past 30 minutes.